network or any sample network we were developed in RSCAD software, and from there we took out the signals, three-phase voltages and currents using the GTAO cards. Then we are amplifying it because the maximum range is plus minus 10 volts. So we amplified it and then we gave it to PMU, and from PMU we were sending it to PDC. Okay, so this setup we have seen. So this is the waveforms that, so the top portions are what PMU is sending and the bottom portions are what PDC is receiving. So now, so both are connected to a single switch. PMU is connected to the switch and PDC is also connected to the switch. And we have seen that in the laboratory session that another system, PC, this PC which I am taking access, so this is also connected to the same switch. So there we have the NetSim software also installed in that system. So we will use that software to create various cyber attacks. So we'll see one by one. So first of all, let us see denial of service attacks. So this is the kind of a sample network that we design. It is a simple one, like PMU is sending the data to PDC. So there is a emulation is going on. So this is emulating the traffic which is actually flowing from PMU to PDC. And also, as Vishal from NetSim told that what we have done is, now the traffic, instead of directly going from PMU to PDC, it is now coming to this device, this NetSim software, and NetSim is redirecting it to PDC. So now this software has the control. So currently, if we don't do anything and we will run the simulation, it will, I will show you that it will not do anything. The traffic will be as it is. So currently it is kind of a sniffing we are doing. So an attacker has gained access to the network and it is just monitoring what is going on. So that I will show you. And then using, so this is just a router. Let's say at substation there is a switch or a router, and at the control center there is another router, and there is a link between this. So in this link we will create various attacks. So here if you see, we will click the link, and first of all, if we do the medium property, and this is how we give delay in this. So this uplink propagation delay, uplink is this one from PMU to this router, and downlink is from this router to PDC. So if we give it in some delay, let's say 50,000, something like that. So even if we give some delay, uh, and here we have simulated, I will make it as, I will talk about this uptime and downtime in a short while. So even if we, so here we are giving a 50 millisecond delay. So if I run this simulation, I'm running it for a 1 minute time. But thing is, delay attack, yeah, so it is running the simulation. But if you see the waveform, you will not find any, means you will not notice the delay. So for that, we can check the Wireshark capture. So so this is a capture of the Wireshark. So if you see, these are the various data frames, and in the payload part, as sir has told you, in the payload part there is, so these timestamps are there, and there is a field called fraction of second. Okay, so here as we have selected 60 hertz system, so each packet is coming in every 16.67 milliseconds. So if you just notice this fraction of second part, and I will just move to down, so you can see each packet is having 16.67 millisecond time difference. Okay, but when we create a, so everything is 16.6 minutes, but when we created a time delay, so now this delay will increase, okay, gradually. Okay, simulation has stopped. So this time delay, so we, instead of the difference 16.67 millisecond, now so the previous was 200 and now it is 233. So gradually, so now it is 400, from 233 to 400. So now it is increasing. So like this, we can detect if there is a delay in the network. So this is a simple just delay attack. The next is the denial of service attacks. So here, yes, ah, yes. So no, okay, closed it or yeah, around this point, yeah. So here the delay has started. So it persists for some time. So now again it is back to 16 milli. Okay, still the attack is there. Yeah, 16.67 as we have selected that 60 hertz system. So for healthy scenario, yeah, it is randomly it is increasing. So here there was a attack and then I stopped, the simulation was stopped, then again it came back to 16 millisecond, and then again you can see actually what happens in the attack is if we are increasing the delay, as we are using TCP transmission, it doesn't means the packets get padded up here, so it waits until that delay time, and at a time it sends, let's say, two packets. So let's say one packet has to reach in 16.67 millisecond, but we have added delay. So after that delay, it pads up with the another packet which supposed to reach after 50 millisecond. So the previous span and this one got padded up, and at a time it is sending. So as you can see, the size of the packet, length of the packet in healthy condition is always 198, but here it got padded up into a single packet and at a time it sent. Yeah, means here it is not a fix like it will add two packets, it can add 10 packets. So this in healthy condition we know that the size will be 198, but in delay it is not fixed like it will be some fixed length of the packet. No, means timestamp is there, so that's why synchrophasor data is flowing from PMU to PDC based on the standard. But it doesn't matter that the PDC is receiving the data with some delay, as you can see in this PDC software also. So this is in the waveform. In the waveform, it is actually you can see it is every 30 seconds it is coming. So that millisecond difference we will not notice in the waveforms. So that is the issue. Any other? Huh? Yeah, the Warsaw capture I saved it. That I was showing. But attack we can do. I mean delay attack as it is not no. So DOS attacks I will show real time. So delay attacks I because we have to show the Warsaw capture. So that's why. Then for the DOS attack, yeah. So here it is the same scenario, but we are using this link failure property. Okay. So here there is something called uptime and downtime. So this is something like at what time, if you are running, it is in seconds. So if you are running it for, let's say, 1 minute, let's say it will be up at 0, it will come down. Down means data will be off at 10 second, then at 13 again it will be up. So it is randomly I have given, so we can see variable drops in a 1 minute window. Okay, so this we can simulate. So here, yes, that also I will show you in Wireshark how it looks like. So now you can see the PMU is sending the data, but it is not getting means received at the PDC. So this is the first window. Then it came again for some time. Then again it is stopping. So like this, based on the time we have given in that link failure, like this, the DOS attack is variable type of DOS attacks we are giving. So now, uh, simulation. This one and this one, right? So this is the actual traffic. PDC means, this is just simulation. Means we are designing, keeping some routers. Actually, this is the actual emulation which directly PMU is sending to PDC. But in the middle, we are adding some hops. Actually, it is not the physical switch. It is not like that. We are just in the simulation. We are just adding some hops or some routers in the middle. So this is in the Wireshark. Uh, so in the Wireshark, you can see here. So it was coming like this completely, and here the data has stopped. So data transmission off, and after some time, it is up again. So like this, it shows. So here we can see that how we calculate the how much time, because we also know from the simulation that how much time we have given for the attack. But here also, by uh, from this point to this point, we can subtract the time, and there also we can know the attack was for how much time. So this is also another way. Where, sir? No, here for healthy it will always be 198, but this is not actually synchrophase. It is trying to as TCP has that three-way handshake, right? So it is sending the request PMU, but it is not getting acknowledgement. So it is showing like this data transmission off. So these are not actually synchrophaser packets. It is just, yeah, that is also another Wireshark capture. It is this one I am showing for just one attack. That also I have. If you want, I can show you. So here we have multiple. So actually the packet in 1 minute, or let's say 2-3 minutes, it generates around 10,000 packets. So So this was one instance where the packet was dropped. This was another instance. So for multiple attack windows also, we'll just run it. We'll first run the Wireshark capture, and then we will run the simulation of attack. And once the complete 1 minute has stopped, we will just stop this Wireshark capture here, and we just save it. So like this, we just capture the data in Wireshark. Yeah, that's sir has told, and that link failure or communication failure is will not be in seconds. It will be in milliseconds or something like that. So if it is in seconds, then we can come to know that it is something wrong has happened. So it is kind of a flag. And our algorithm, which we are reconstructing also, even if the attack is for seconds or in milliseconds, if there is a link failure also, we can reconstruct those packets. So it doesn't matter that if it is in seconds or minutes or in milliseconds, how much time there was no data, we can reconstruct it. Whether it is link failure, it is DOS attack, anything like that. So, and if we delete it, just same scenario. So same scenario, I have just deleted this link. So what will happen? It will the for as much time we run this, I'm running it for 10 seconds, the data will be off. So like this, we have created that 10-second attack. So here the attack, the moment I started the simulation, the attack has started and it will be there for 10 seconds. Yeah, the simulation has stopped, the data has again started coming. Only DOS attack was previously there, but the things which I will show now, that replay attacks and false data injection, that was developed later. Yeah. So these were DOS attack scenarios. Then yeah, this one. And this is which we are redirecting the traffic. Okay. So this I have stopped. Yeah. Yes. And yeah, that is true. Yeah. Yeah. So if we just, as I've shown in the first, I will just click it. I will just connect it, and I will not do anything. I will not give any attack. So it will just, the data will be same as it is coming now. It will not do anything. So that is kind of a sniffing. The attacker is present, but he is not doing anything. So that is the sniffing type of attack. But when we give some delay or we stop the link, then we can create DOS attacks. Same network switch that we have shown. This is the monitoring software of SCL. So upper portion is showing PMU data, down portion is showing PDC data. Same network. Yes. Yes. Yeah. That is also like the rule based and firewalls, those things also do the same. So there, that is IT level security. So if attacker is present or not, and the firewall has detected some unauthorized person is there, so that is the one way. And this is like OT security. I mean, the attacker was there, but the data wise, we have to know that whether it is an attack or something like that. Yeah. Yeah. Data will flow everywhere means. No, this is this is not kind of a broadcast message. It is like we in PMU settings we have given the IP address of the PDC, so that PMU will send to that PDC only. It will not send anywhere else. Yeah, goose message is kind of a broadcast messages. So this will only send it to PDC. We have given the IP addresses at the PMU settings, and in PDC also we have given the port number and IP of the PMU. So both knows their IP addresses, and this communication is established. So next we will see the replay attacks, or false data or replay and attacks, all and false data injection attacks all fall under this category of integrity based attacks. So we will see that. Yes. Yes. So so this path is actually emulating the actual traffic. Okay, I'm not clicking and showing here because here IP addresses are given of this of this node and this node. Okay, so this green line is actual traffic, and this we are changing something, we are simulating in this software, that instead of this traffic it will follow this path, and we are doing something in this path. So this software is doing that. Instead of directly sending, it will come to this software, it will do something here, and it will redirect. Yeah, it is directly sending, but no, there is, it is not a copy of the path, it is actually changing it. Yeah. Yes. Yeah. Yeah. Yes, yes. So in this emulation, we have given in this general, I will not show here, but here we have given the IP addresses of this node, which is the PMU, and here which is the PDC. Yes. Yes. Yes, yes. So you are saying here this is PDC, this is PMU. So means if, yes, yes, it is just like what actually attacker does. It has the, yes, in the reverse case the PMU, but that no, who is sending data to whom? In this here, yeah. Acha, if you are yeah, correct. If you are attacking the PMU itself, it is not, it will not send data to PDC. Yes, we are just attacking the switch. Actually this PC is at that switch. We cannot attack the PMU directly through this here. it should be at the middle or at the switch level or at the hub level. Yes. Yes, that is the first part to get into the. Yeah, yeah, but actually he will attack the communication. What is happening? If PMU is sending, let forget about PMU PDC. Any I2 IDs. Yes, yes. ID1 is sending data to ID2. He will know the IP addresses through the Wireshark, and he can just, if he knows about the traffics a little bit, he can decode and all these algorithms he can do, and he can attack. हाँ मैंने वही बोला. हाँ हाँ वो हाँ here also means our college won't allow. Yeah. Yeah. Hmm. Our means network provider means. No, 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 that we can. Now let us see some FDI and FDI attacks. So for that, this is the new kind of development that we did with NetSim. So they have given this UI with for us. So here we have different kind of attacks here. So we can see one by one. So random is randomly it will do some attacks. So if I have started, so it's randomly after this point. So PMU is sending healthy data, but at randomly it is doing some attacks. Then let us first stop it. Okay, so second is the increment type of attack. So now it is healthy again. So increment as this is in kilovolt. So if I give 1% or 0.1% also, it will reach megavolt in very few times. So I've just given very small value 0.0001. So if I start, it will be, so this means like from previous value, 0.0001% increase. So it is kind of a ramp where the slope is this percentage. So here, and in the current also it is increasing. So after this point you can see it will be, so now also it is increasing, and then we can select decrement type of attack also. I will just modify it. So now it started decreasing. Then this is the custom attack. So these are some attacks which we can it is by default given in this UI. And if we want to develop something of our own, like based on the previous value, like we know that bad data detection, it has some calculation of residual, and then there is a threshold. Above that, if it crosses that threshold, bad data detector will detect it. So we can develop some code like that. It should never violate that threshold. So if you want something custom logic you have, so we have to select this custom mode, and then in the netsim it opens Visual Studio. In C++ programming is there we can give our own logic. So here, yes, that I will show you. I will show you just now. So this is custom. And the attack is not only happening, I am just showing here phase A voltage magnitude and phase A current magnitude. It is actually happening for all the phases, all 12 phases, frequency, everything. I will show you. I will show you. This is just custom attack, some different logic. And then if we select this manual mode, so now you can see we can select a particular phasor. Let's say I want to attack only VA phasor and not nothing else, nothing else. So let's say, oh, let it be 1 volt. So it will, the VA voltage will drop down to 1 volt. Okay, but current is at it, as it is. We are not attacking any current also. So like this. And if you want to change the frequency, by default it is not enabled. We can click on the frequency. Let's say I clicked on the frequency, and here there is a, so here you can see the frequency has changed to 50 hertz. Okay, and yeah, then we can select this replay attack. Here it is asking the replay length. What it is asking is how many packets before a particular point where we will start the attack, previously how many packets it will take. So here if we select 10, let's say we select 100. So okay, so let me stop it first. Where? Here? No, it is megahertz per second it is showing. Here it is showing the actual frequency value. Yeah, it is actually frequency value it is showing here. Okay, so if we select this 100 here, so from the point of attack, previous 100 packets it will take, and it will just replay. So if we start this, so here if you can see, it is just replaying 100 packets. So after some point, So like this, it is replaying 100 packets. And if I stop it, and there is one more is file based. Okay, so we can give a CSV file. So let's say I have taken this CSV file. Yeah, so these 10 packets I will replay. Okay, so in the CSV also we can give custom values also based on our requirement, and I will start it. So it will just run those, because in the CSV file it was the voltage range was 129 something. So the voltages has dropped to, so that's those 10 packets it is replaying. So like this we are creating different kind of FDI attacks also. And yes, yes. Yes, yes, it will show the same value as you are seeing in this Wireshark, but the values will be what we are changing it. Okay. No difference delay also we are not adding. It will be same 16.67 delay. Only the values will be changed. So this 129 it will show. Okay. And one more thing in the FDI attacks, what we need to take care is the checksum. So if we are manipulating some value, and if you don't take care of the checksum, it will in the Wireshark it will show as bad checksum, and the data will not. It will just skip that change. And so we have, while manipulating the data, we have to also recalculate the checksum, and that corrected checksum also we have to send as a manipulated value. So if you see the Wireshark, this this last value is, so this last value is checksum. Okay, here it is correct and good. Okay, but if you don't take care of the checksum and when you try to manipulate some value, it will show as bad. It will not show good, and this data will, this packet will get skipped, so it will not perform any attack. So you have to take care of this checksum also. There is checksum formula is available in the means it is there in the standard itself. So like that we have to calculate the checksum also. So yeah, and the same thing we have done this. So this is all for synchrophasor packets. All the same thing is we have done for DNP3 also. Maybe quickly Aparna will also show uh, 2 3 DNP3 scenarios.
Okay, so okay, so in similar way, like for example, PMU PDC communications are affected by using NetSIM, and how it is done, it has already been shown. Similar way, if we take another example of communication, say in between an RTU and SCADA communication, so similar way, NetSIM can intrude and we can perform attack. So we have the same UI based attacks we have created. The delay and DOS or maybe availability based attacks, similarly, we can simulate into NetSIM and perform the attacks. Regarding the data manipulation category of attacks, same UI is developed, UI based various attacks, for example, zero injection or maybe transient input of maximum float injection, which can mimic maybe any transient event of the power system, or slight amplification, very gradual increment or gradual level of FDIA increment or decrement we can implement. Similarly, custom based attacks also we can do, like we can write our own code, write our own logic for the attacks, and dump it into netsim and then implement it. Similarly, manual mode is there. Manual mode is there, like we can manipulate each and every data point based on our requirement. So based on scenarios generation, maybe only voltage measurement of certain bus we need to manipulate and not disturbing rest another bus. So these scenarios also, like data point 1 2 3 4 5, based on the DNP3 healthy communication, we can manipulate that. Based another attacks are like CSV or PCAP based attacks, like we can give our own file to it. For example, replay attacks are there, which are like the attacker records any previous healthy scenarios or maybe previous faulty scenarios, then keeps it to themselves and then replays it, while to mask maybe healthy conditions or to mask any system contingencies, so that so to disturb the decision making. So for that, we can generate our own CSV or own PCAP. We can record the healthy scenarios from Wireshark and then give it while performing attacks. So replay attack scenarios also we can implement using this. If we have to visualize this, so sample visualization I can show you. Custom attack logic. No, sir, it is developed for us. Developed by us along with NetSim actually. Okay, so visualization of attacks, I already told you that we can develop at, for example, at destination level or a SCADA level, our own HMI, where we can visualize the real-time trends of voltages and currents. So healthy data we visualized earlier. For example, here are few of the sample attack cases, which we can visualize, like what impact they create on our power system data set. This is one of the custom attack, maybe poison attack we distributed, just in intrusion of any noise into the healthy data. So you can see the healthy data just changes. It will change to certain pattern which might look like healthy data, but it is actually not. These are the manipulated values actually. Then we have another scenarios, say amplification type of attack, in which very gradual, maybe small values we inject into the system. So just the pattern slightly varies. Then we have zero injection attack, maybe just making the all the values suddenly to the zero for given time duration. So making the actual available measurements non-available for certain durations. So we can see the values dropping down to zero in here. So basically what we do, that we create various scenarios of healthy and attacks. Real-time Wireshark monitoring we do. So from Wireshark, we can directly, we wrote our own code, maybe custom parsing we do. We extract the data of all the scenarios, healthy attacks, various attack scenarios, so that we can extract the values and make our own algorithms to detect such attacks or maybe to mitigate such attacks. So we use all the data by Wireshark parsing and writing our own custom codes. Okay. So any doubt, any question? DOS attack we can, same sir, same scenario, just like sir explained to you in NetSim. We can make our source and destination, and then maybe in simulation making a, actually the simulation was kind of simulation of network level, how at the network layer the data is transmitted, maybe hopping through various routers and everything. So as Soumya sir already showed you in that NetSim, similarly just PMU and PDC, replace it with your another devices. So emulation and then via routers we can create like dropping the links or dropping the connection. So similarly, in similar way, we can develop the DOS attacks or not. So it is, sir, actually, for example, that was for C37.118 synchrophaser work. This work is for DNP3 also. So protocol intricacies also, like while writing, developing your own codes, we have to take care of the protocol standard also, like उसका ध्यान रखना पड़ेगा सर. कस्टम, इसीलिए हमने अपना कस्टम यूआई उसके लिए डेवलप किया, क्योंकि नेट वहाँ अटैक के लिए. हाँ सर, एनी वैल्यू, whatever Wireshark can monitor. Yes sir, exactly, we can do this. False control command. False control command. Yes, we can do that. For example, switch circuit breaker status 0 to 1 हमने अगर कर दिया वापस, we can do that. Yes, sorry sir. Actually tripping by false command. I don't know. Hmm. You have to develop that. Okay sir.
Yeah, so if the attacker somehow gets access to the system, right? Right? So if you have role-based, first of all, they will not be allowed to get access to the system, right? Because they do not have the role, right? But obviously, if they got access to the system, then they can do it. Yeah, they are actually yeah, so obviously they are able to. This is why, when you do the segmentation, right, you have only one conduit where you have the firewall, right? So if you have a firewall in this case, right, then it will not be possible. And obviously you will catch it that this is unauthorized. Somebody unauthorized is trying to do this, right? Because firewall will have those rules. It will only allow the traffic from, authorized people to go through. Right? So if you have firewall, then it will not be possible, right? But if somebody is trying to say issue the command right from your device itself, and then role based will stop it because they do not have they will not be given access to it, right? So that's why a defense in depth strategy, you have to have all these layers, right? If somebody got hold of your channel and and at the channel level they are trying to manipulate the data like they are doing, they are actually manipulating it at the channel level, right? Then obviously you need some other mechanism to uh, to stop that, right? Firewall could be one of those, that at the other end, wherever the command is going, there you have the firewall. That's why we are trying to reduce in segmentation, we are trying to reduce the number of conduits. It's only one connection, and there you have a check, right? So in this case, in the case of PMU and PDC, we talked about that, right? TLS you can use, right? So we have I think you're going to get those notes. We did talk about that yesterday. How do you secure PMU messages? So you can use all those strategies.